So in this tutorial, we're going to cover the most significant aspects of projectiles. Okay, so I'll read the question out loud, then we'll start attempting the question from A and to D. Okay, so the question is saying that an object projected with velocity x, right? We can see that from the diagram, the object is projected with a velocity x here, right? At an angle theta to the horizontal, okay? The angle theta to the horizontal, right? So this is the projection. So we're going to do some calculations here. Okay, so given that theta is equal to 30 degrees and x is equal to 100 meters per second, assuming that g, the gravitational acceleration, is 9.1 meters per square second, find A, the maximum height, which is here. So in this tutorial, we're going to find the maximum height. Then we're going to find the time of flight. So the time of flight is the total time the object will travel from this position to the rest position. That's the time of flight. Then C, we're going to calculate the range. The range, which is the total distance, horizontal distance traveled by the object. The total horizontal distance. Then also we are going to calculate the speed when the object hits the ground. Okay, so this is a tricky one. So the object is projected with a certain speed x, and obviously when it returns to the ground, it will return with a certain speed. Okay, with a certain speed x2. So in question D now, we are going to calculate the speed x2. That is quite a tricky one. Most students find it difficult. Okay, so let's start with question A. We're starting with question A. And question A is demanding that we find A, the maximum height reached by the object. Okay, so what do we know from the question? From the question, we know that theta is equal to 30 degrees and x, the velocity of projection, the initial velocity of projection is 100 meters per second. So h, we are calling the maximum height h. Okay, so from the diagram, the maximum height is h here. Okay, so whenever you're calculating projectiles, they have two components. Okay, you have to take note of two components. There is the vertical component and there's the horizontal component. So the initial speed is 100 meters per second, right? And the vertical component of this speed is 100 sine theta. Okay, 100 being the velocity of projection, sine theta, the angle of projection. Okay, so the angle of projection is 30 degrees, right? So therefore, the vertical speed, the vertical velocity of this projection is 100 sine theta, and also the horizontal velocity of this projection is 100 cos theta. Okay, so let me punch these into my calculator. Okay, so if you punch 100 sine theta into your calculator, you will get 50. So meaning that vertically the object was traveling at 50 meters per second, right? You just have to make sure that your calculator is in degrees, right? And also, if you punch 100 cos 30 degrees, you get that the vertical speed of the projection will be 86.6 meters per second, right? So therefore, we have our initial values now. So we need to begin our calculation. To find the maximum height now, we're going to use this equation. V squared is equal to U squared plus 2AS. Okay, so the S is for distance, A is for acceleration, V is the final velocity, and U is the initial velocity, right? But we know that we are considering the calculations in the vertical component now. So A is going to be the acceleration due to gravity, right? So A equal to G, right? The gravitational acceleration, right? Then S, the distance traveled until the maximum height is equal to h. So we are going to represent the maximum height with h. So S is equal to h. So I now substitute this into the equation. So therefore, and also there's another aspect which I almost forgot, is that the final velocity at the maximum height is equal to 0, right? So the final velocity at the maximum height is equal to 0. So 0 squared is equal to U squared plus 2GH, right? H being the maximum height. So therefore, oh, this is U. So our purpose here, we're answering question A, and we need to find the maximum height. So therefore, we're going to make h is the subject of the formula, right? So if we make h the subject of the formula, the equation will look something like this: negative u squared over 2 over 2g. But there's another aspect I want you to consider. So the object was thrown up, right? This is the object. Okay, so when the object is traveling up, g is equal to negative g, right? So we're going to put a negative here. Okay, so you're seeing that from the equation, a negative will cancel out a negative. Therefore, h will be equal to u squared over 2g, right? So u being the initial velocity of projection, right? Earlier, during the start of the video, I showed you that the initial vertical velocity is going to be equal to x sine theta, right, in the vertical direction. And the velocity in the horizontal direction is going to be equal to x cos theta, right? This is the horizontal direction and this is the vertical direction. And we did some calculation, then I'll show you that x, which is the velocity of projection, which is 100, and theta, which is 30 degrees, right? So according to those variables, 100 sine theta, the vertical velocity, u, is 50 meters per square second. 30 sine theta, 100 sine theta is going to be 50. So this is u, right? The initial u in the vertical direction. And x cos theta, which is 100 cos 30 degrees, is going to be equal to 86.6 meters per second. This is u in the horizontal. And this is u in the vertical. Okay, so let's get back to our calculations now. Okay, so since we have calculated u in the vertical direction and found that u is equal to 50 meters per square second, so we are now just plugging in those values into our equation. So h, the maximum height, is equal to the initial vertical velocity, which is 50 squared over 2g. What is the acceleration? From the word go, the question told us that assuming that g is equal to 9.81 meters per square second, right? That's what the question is saying. So we're assuming that g is equal to 9.81 meters per square second, right? Okay, so this is our calculation now. Okay, so if you plug this into your calculator, so if you punch this into your calculator, you get that h, the maximum height, is going to be equal to 127.4, correcting to one decimal place, right? So we know that h is height, height is distance, distance is measured in meters, so we put m for meters, then you're done. So we are moving on to question B now. So before we proceed on to part B of the question, do me a favor and subscribe, and I'll always be here to help you get better at physics. Okay, with that being said, let's get back to the question. Okay, so we've calculated part A of the question and we found that the maximum height h is equal to 127.4 meters. That's the maximum height reached by the object, right? 127 meters, 0.4, right? So right now we're now moving on to part B of the question, which is the time of flight. And I want you to take note of something. The time of flight is twice the time taken to reach the maximum height. Okay, let's say the time taken to reach the maximum height is t. Time taken to reach maximum height is t. Okay, I hope you're seeing it clearly. Let's say the time taken, assuming that the time taken to reach the maximum height is t. So the time of flight means that the time taken for the entire travel from this position until the entire flight until the object returns back to the ground, right? So the time of flight is equal to times 2 the time taken to reach the maximum height. So therefore, is equal to t. So t, time taken to reach the maximum height, times 2 is equal to t. T, the time of flight. Okay, so let's calculate now the time taken to reach the maximum height, and we times it by 2, which is equal to the time of flight. Okay, so to find the time taken to reach the maximum height, we're going to use this equation of motion, which is v, final velocity, is equal to acceleration times time plus u. We all know this equation, right? U being the initial velocity, v being the final. So I've said this and I'll say it again. At the highest point, the final velocity is equal to 0, right? At the highest point, the final vertical velocity is equal to 0. So therefore v is equal to 0, and we also know that a is equal to the gravitational acceleration g. So since a is equal to g, a being equal to g, but when the object is going up, right, it means a is negative, it means g is negative. So therefore a is going to be equal to negative g, right? A is equal to negative g. So we're going to substitute a with negative g. So negative g times the time t plus u. Okay, so let's make t the subject of the formula in this equation. So if we make t the subject of the formula, we're going to end up with something like if t flies to this part of the equation, we're going to end up something like the subject of the formula. The equation is going to look something like this: u over g, right? So the time taken to reach the maximum height is going to be equal to the initial velocity divided by what? The initial vertical velocity divided by g, the gravitational acceleration, right? So the initial vertical velocity, we know that t is equal to 100 sine 30 degrees over g. G from the question is told us that assuming that g is equal to 9.81 meters per square second, right? So g is 9.81 meters per square second. And also if you pass this into your calculator, 100 meters sine 30 degrees, the vertical, this is the initial vertical velocity, right? So if you punch this into your calculator, you find that t is equal to 50 meters per square second divided by what? By 9.81 meters per square second, the acceleration, right? I hope this is clear to everyone. So if you punch this into your calculator again, so 50 divided by 9.81, you're going to find that t is equal to 5.1, correcting to the nearest decimal place, seconds, right? So this is the time taken to reach the maximum height. But from the word go, I've told you that the question B is saying that we should calculate the time of flight, of which the time of flight is equal to times 2 the time taken to reach the maximum height. So we've calculated the time taken to reach the maximum height, and we found that it's equal to 5.1 seconds, right? Times 2 is equal to t, the maximum height. So therefore the maximum height obviously is going to be equal to 10.2 seconds. Okay, so this is the maximum height, 10.2 seconds. So we're now moving on to find the range. Okay, so we're now moving on to the horizontal component of the projectile. Okay, so this is the range. I've told you earlier that this is the range, the total horizontal distance traveled by the projectile, right? So I want you to take note of something. I want you to take note of something. What is the horizontal velocity? What is the horizontal velocity, or the initial horizontal velocity? I've told you earlier from the question that the horizontal velocity of the projectile is x cos theta, in which x is the velocity of projection. The velocity of projection from the question is 100 meters per second. This is 100, which is 100 meters per second cos 30 degrees. What is 30 degrees? 30 degrees is the angle of projection. That's the angle of projection. So therefore, the horizontal velocity of the projectile is 100 cos theta, which is equal to 86.6 meters per square second. And there's another trick I want you to take note of. The horizontal component doesn't change since we have no horizontal acceleration, right? So the horizontal speed, the horizontal velocity will always be constant. So write that down. Okay, so we're going to use that to calculate the range. Okay, so I want you to pay more attention now to this simple trick now. So I'm giving you the formula to calculate the range. For you to find the range, the formula is equal to x cos theta times t, where t is equal to the time of flight, right? So from the word go, when this tutorial started, we calculated the horizontal velocity of the projectile, and we find that x cos theta is going to be equal to 100 cos 30 degrees, which is equal to 86.6 meters per square second, right? So the horizontal, the range now, the range is going to be equal to 86.6 times t, time of flight. And from the word go, we've also calculated the time of flight. We found that the time of flight t was equal to 10.2 seconds, right? So therefore your range is just going to be 86, 86.6 times 10.2. You point that into your calculator. Once you point that into your calculator, you find that the range will be equal to 883.3, correcting to the nearest first decimal place meters, right? Okay, so that would be your range, 883.3 meters. Okay, so we're now proceeding on to question D now. So this is a tricky, I like this question a lot because most students get confused, right? So the speed when it hits the ground, so it's referring to the object, right? So we know that this projectile was projected at speed 100 meters per square second, right? That was the speed of projection, the velocity of projection. But when the object reaches the ground again, it should have a certain speed. Okay, that will not be equal to x, right? So we want to find x2. So we know that from the question, an object projected with velocity x being 100 meters per square second. So right now we want to find x2 now. x2, the velocity, the total velocity. So right now we're not talking about the vertical or the horizontal. We want the speed in total when the object reaches the ground, right? Okay, so in this part of the question, I'm going to do the calculations on the sheet because I want to clarify something. So vertically, this is the vertical component, right? And this is the horizontal component. And we know that this horizontal component is x cos theta. And from the word go, I've told you that it does not change, right? I've told you that the horizontal speed does not change, which means it will remain 86.6 meters per square second, right? So the challenge is with the vertical now, since it is under influence of acceleration. Okay, so the challenge from this question is finding the vertical component of the velocity when it reaches the ground. So to find that, we are going to use this equation, right? So V is equal to AT plus U, right? So I want you to pay more attention because I'll be explaining something that might be a bit confusing, right? So when the object starts returning to the ground, this becomes the initial velocity, vertical velocity. This becomes the initial vertical velocity, right? But we've been told, and I've also told you that at the highest point, the velocity is 0. So when we are now calculating the velocity, the vertical velocity when the object reaches the ground, our initial velocity of projection becomes 0 because the object is now starting again to accelerate onto the ground, right? So and the object when the object starts falling to the ground, we know that the acceleration becomes g, and the g will be positive, right? When the object is going up, g will be negative, and when the object is going down, g will be positive now, right? Will be positive, right? And the third thing I want you to take note of is that the time taken from the maximum height to reach the ground will be the time of flight divided by 2, right? The time of flight, time of entire flight, we calculated it and we found that it was 10.2, right? 10.2. So 10.2 divided by 2 will be the time taken from here unto here, right? So we know that the time taken to reach the ground from the highest position will be t is going to be equal to 5.1. I hope you're seeing this clearly. Okay, so let me just use my marker. Okay, so t from the highest position, this t from the highest position onto the ground, t from the highest position onto the ground will be 5.1 seconds, right? And acceleration AU will be equal to g, and it will be positive, right? Acceleration will be positive, and the initial velocity when the object starts returning to the ground will be 0. Why is it 0? Because it's starting at the highest point, and at the highest point velocity is 0, right? So we are going to use this equation now. We're going to use this equation. V is equal to a t plus u, right? So t being the time taken to reach the ground from the maximum height. So the time taken to reach the ground from the maximum height, I've told you that it's 5.1 seconds, right? So the final velocity, the final vertical velocity when the object reaches the ground is the one we are calculating here. So v being the final velocity will now be equal to a is equal to g. The acceleration will be positive since the object will be falling. So g is 9.81 meters per square second. So 9.81 meters per square second times what? Times time. Time taken from the maximum height onto the ground, which is 5.1, which is 5.1 seconds, right? Time of flight divided by 2. Time of flight divided by 2, and t being the time of flight, right? Then r plus u, and I've told you that u will be 0 since the object will be now starting at 0 again, accelerating onto the ground vertically. We're at this point we are just considering the vertical velocity of the object, because I've told you that the horizontal velocity will be constant, will be x cos theta, which will be equal to 86.6 meters per square second. The horizontal will stay constant, right? So if we punch this into okay, I've told you that plus u what, and we found out that the maximum height u is 0. We know this from projectiles, right? So from the maximum height, u is going to be equal to 0. So therefore, v is going to be equal to 9.81 times what? Times 5.1. Right? So if you punch this into your calculator, if you punch that into your calculator, you find that v will be equal to 100.01 meters per second. So this is the speed by which the object will reach the ground, right? We hit the ground. Okay, so we are done with projectiles. So I'll be uploading for those of you who require more questions for practice. I'm uploading another video just soon after this video. So it will be for your benefit if you subscribe and you turn off the notification, so whenever I upload the video, you'll always be notified.